of the AAS theorem, what we're about to do here. So they have some given information for us, and that's how we always start out our proof. So I'm going to go ahead and copy that down as my given. So I know that angle N is congruent to angle D, angle G is congruent to angle I, and that side AN is congruent to side SD. And my reason for all of that information is given. Okay, so I'm going to go ahead and mark that over here on this image. So I know that angles N and D are congruent. Give them one mark each. G and I, also congruent angles. I'm going to give them 2 marks. And that side AN is congruent to side SD. So we already have 3 pieces that are congruent, right? We've already proved that the triangles are congruent. That's not what they're asking us to prove. We already know the triangles are congruent. They want you to be able to say that because these are congruent, we know that means all the other pieces are congruent as well, right? So another way that you could go about saying that is by marking something else, and then it could be congruent by something besides just AAS, right? So there are multiple things that you could pick to mark and then make it congruent by another postulate. Maybe we choose to make that third angle congruent. Okay, so if I was to mark that, that would be for angles S and A, right? So because the 2 triangles are congruent, which we already know, I can now say that I know that that means angle A is congruent to angle S. So I didn't just make that up. It's because we already knew that the triangles are congruent that I can make that statement. This is actually something that's called the third angle postulate or third angle theorem. You don't need to memorize that or anything. It's not something that you're going to have to use all the time. But there is a theorem that says if your 2 triangles are congruent, then you know that that third angle is congruent. So now that I marked it by having this congruent angle, what other postulate are those 2 triangles congruent by besides just AAS? ASA, by what we have marked, right? We've got a side in the middle of 2 angles. Very good. All right, so now I can not only say that those 2 triangles are congruent because of AAS, I can say triangle ANG is congruent to triangle SDI by that angle side angle postulate or theorem. All right. And here in just a second, you'll see why it's important that we know that this is true. So just a few reminders on things that it's helpful to always be looking for whenever we do our proofs. So first of all, if they give you some information, make sure you always go over to your drawing and mark that information down. Because it might not be explicitly saying side AB and side CD are congruent. It might just say that something is a midpoint. So then you need to go over to your picture and mark, okay, if this is a midpoint, what does that mean? Okay. Second thing, if you're someone who likes to color coordinate or highlight important information, maybe use different colors when you are marking on your drawing. Okay. But on top of all that, we said that there are certain things that we're allowed to add in that they may not have marked for us, right? So you always need to look for those pieces. First of those being a shared side. If I have a shared side, what's the reason for it in my proof? Good. Okay. We also know that we can look for a couple kinds of angles. Vertical, good. When we have vertical angles, what do we mark them as? What do we know about vertical angles? Congruent, good. It is always congruent, very good. All right, then also yesterday we talked about a couple of different bisectors. What were those different bisectors we talked about? So first is the angle bisector. If you have an angle bisector, what does that do to your angle? Into two congruent angles, right? Good. So it'll cut this into congruent angles. All right, and then he said the second one was the segment bisector, which creates, right. Good. All right, so for number 7, what's the last type of angle pair that we're allowed to mark? Alternate interior, but we have to have what kind of lines? Parallel lines and a transversal. So you've got to have parallel lines to prove that you have those alternate interior angles, which we know to be congruent. Okay, so CPCTC. This is the reason that we did that proof up there at the top, to remind us, once you know that your triangles are congruent, even the pieces that you weren't able to mark while doing your proof are going to be congruent now, right? All corresponding pieces are congruent. And that's basically what this property says. It says sometimes the ultimate aim of a proof is not just to prove that your two triangles are congruent, but that parts of the triangle are congruent. So it may not say, given, blah, 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 prove triangle ABC is congruent to triangle DEF. They might say, prove angle C is congruent to angle F. Okay? And in order to do that, I may have to completely prove that the two triangles are congruent, and then I can say that those two angles, even though I couldn't mark them, I know they're congruent now. Okay? So we use this in proofs after proving that your triangles are congruent. So, in order to use CPCTC, you have to already have proven that your triangles are congruent. Okay? And what does CPCTC stand for? It stands for corresponding parts of congruent triangles are congruent. That would be a long reason to write down in your proof every time, so that's why we use the abbreviation of CPCTC. All right, so if you were to use this in a proof, what does that look like? Okay, well, first of all, you have to have already proved that your triangles are congruent. So the proofs that we were doing yesterday, that's what you would want to do. You're given, mark 3 things, and then say triangle whatever is congruent to triangle whatever by SAS or whatever it is, okay? So first step would be to go ahead and prove that triangles are congruent using one of our postulates, like SSS, or SAS, or ASA, or AAS, or HO. So basically do the proof that we did yesterday. That's your first step in the process. Once you have proven that your triangles are congruent, whatever piece it wanted you to prove is congruent, that is what you're going to put as your next statement. Okay? So in your statement column, you will state which corresponding parts are congruent. And then once you've made that statement, the reason for your statement will be because corresponding parts of congruent triangles are congruent, or C, P, C, T, C. All right? Okay, so once you have that written down, if you'll flip it over, we're going to do an actual proof where we apply this so you know exactly what it looks like. All right. So, let's see, here on number 1, it says to write a proof. We have some given information. If you notice, this time, it doesn't say prove the two triangles are congruent, right? So I'm going to have to still go about proving that the two triangles are congruent before I can prove this part right here. So what am I going to start my proof with? Okay, so I have that NP is perpendicular to MO, and that point P bisects MO. And my reason is given. Okay, so I'm going to come over here to my picture and mark all of that information. So if NP and MO are perpendicular, what does that mean I'm allowed to mark?
Angle NPN and NPO are right triangles.
Right angles. Yes, we have right angles. Very good. Okay. Then it says point P bisects MO. Right, we got two congruent segments. Okay. And then is there anything that they didn't mention that we know we can mark? Shared side. Okay. So do we have three things now? Okay, so now I just need to go back over to my proof, make sure we mention those three things, and then I can say my triangles are congruent. All right? So let's see here. Which one do you guys want to mention first? What do you want to start with? Angle bisectors. Okay. So bisector, it didn't necessarily say they bisected, it said they were perpendicular, but yes, we can start there. So the angle at P on either side. So I would say angle MPN is congruent to, what would I name the other angle? Good. Okay, and why did we know that those were congruent?
The definition of segment bisector.
So not bisector, what did they say they were? No, what did they say they were? Perpendicular. Definition of perpendicular. So they didn't mention a bisector on that one. Okay? Then what do you guys want to state next? The shared side? Okay, so what's the name of that shared side? Good. So I would say NP is congruent to, right? And what's my reason? Good. Okay, so we've mentioned the right angles, we've mentioned the shared side. What's the only thing left to talk about? The what? The two segments, right. So I would say that segment MP is congruent to segment OP. And what would my reason be there? Good. Definition of segment bisector. So this one did mention bisector, right? It said P bisected that line segment. Good. Okay. And you guys said that this is enough to say that my two triangles are congruent. So that's going to be my next statement. Triangle MNP is congruent to triangle, what would I name the other one then? ONP, good. By which postulate is this true? Very good. All right, so we've now proved that the two triangles are congruent, but we were not able to mark that MN and ON were congruent, which is what they wanted us to prove. However, since we've proven that the two triangles are congruent, that means all of its sides and all of its angles are congruent now, right? So now I can make this as my last statement. MN is congruent to ON, and we only know this is true because we proved the triangles are congruent, right? Which is that property that we just talked about on the front. Congruent parts of congruent triangles are congruent. All right, so basically it's the exact same proof that we were doing yesterday. You just add an extra line at the end. Okay. All right, let's do another one. Okay, so how am I going to start this next proof off? With the given. So I have PQ is congruent to RQ, and that S is the midpoint of PR. And my reason is given. Alright, so I'm going to go over here to my drawing and mark all that information down. So PQ, this segment here, is congruent to RQ, this segment over here. And S is the midpoint of PR. So what does that mean? Very good. Okay, so that's two sets of items. Is there anything not marked that we can add? Shared side, good. Alright, so now we have three things. Is this enough to say these two triangles are congruent? Okay, then I just need to make sure that all of those get mentioned in the proof. Okay, well the first one, PQ, RQ, already stated, right? They already said those are congruent. So, the second thing that we mentioned was that PS and SR are congruent. So I'm going to say that next. PS congruent to SR. Why were we able to say that? They said segment bisector right here. What did they say? Midpoints. So that's my reason. Definition of midpoints. You know, midpoint means it's right in the middle, so it must split it in half. Okay, and then the third thing that you guys told me that we could mark over here was the shared side. Okay, and what's the name of that shared side? Okay, so QS is congruent to QS by what property? Good. Okay. So you guys said that that would be enough to say that these two triangles are congruent, so now I'm going to make that statement. Triangle PQS is congruent to triangle, what would I name the other one? Good. And for what reason are they congruent? Good. Alright, so I proved my triangles are congruent. What did they want us to prove? Okay, so that's what I'm going to add next. Angle P congruent to angle R. And what would be my reason? Good. Good job. So, basically exact same proofs as what we were doing yesterday, just add that line at the end. Okay. What did you guys notice about line QS in this drawing? It's a dashed line, right? So, sometimes a dash or perforated line can be referred to as what they call an auxiliary line. So, if they are telling you to look at the auxiliary line or to make some mark on the auxiliary line, that's what they're referring to, perforated line, okay? So just for future reference. Okay. Alright. Now for this last one, I want to make sure that you guys have a few minutes to work on the assignment. So I know it says to do with your partner, but we're going to go ahead and just do it together, okay? So it says do the following proof with your partner, but it starts out with a given and a proof. Okay, this picture, do we have two triangles in this picture? Okay, so we must not be proving that two triangles are congruent here. Okay, so what we do have is that we have some given information, which we know that's how we always start our proof. So I'm going to go ahead and write that part down. I'm given that HT is congruent to HA. Reason given. Alright, so I'm going to come over here to my drawing and mark that. So here's HT, here's HA. Okay, so like we just said, there is not going to be us proving that two triangles are congruent. All we know so far is that in this one triangle, two of its sides are congruent. What kind of a triangle has two congruent sides? An isosceles. In an isosceles triangle, which we now know that this is because it has two congruent sides, not only does it have two congruent sides, it has two congruent angles as well. Okay, so I'm going to add that to my proof here. I'm going to say that I know that this triangle, I'll give it a name, we'll call it HAT. Okay, so triangle HAT is an isosceles triangle. I'm going to abbreviate isosceles there. Okay, we only know that's true because we know the definition of an isosceles is that it has two congruent sides, right? So this is true because of definition of isosceles. Okay? All right, and then, like Tristan just said, that means not only does it have two congruent sides, it also has two congruent angles, right? So what would have to be the two congruent angles? Right. It's always the ones that are across from those congruent sides, right? So now I can make that statement as well. Angle 2 is congruent to angle 4. Again, we just know because we know it's an isosceles, so by definition of an isosceles triangle. Okay, and that's about all we can pull from knowing that it's an isosceles, right? Okay, I'm supposed to be proving that 1 and 3 are congruent. Those are not connected in any way. But is there anything that's not marked that we know is true? Yes, very good. I can mark those vertical angles here and here. Okay, so now I can say that angle 1 is congruent to angle 2 because, like you guys said, those are vertical angles, which we know to be congruent. And I can say the exact same thing about angles 3 and 4, right? So angle 3 congruent to angle 4 for the same reason. Vertical angles are congruent. Okay, so if 2 and 4 were congruent, and now I know that 1 and 2 and 3 and 4 are congruent, can I draw the conclusion that 1 and 3 would be congruent? So I can say angle 1 is congruent to angle 3 by what property?
Transitive.
What is the transitive property? Specific order. Angle A, which would have to be 2, because that's the first one we mentioned, equals C. Okay? But what is this? That's not A. Substitution. Now, if you have yours written in a different order than me, then yours could potentially be transitive. But remember, order does matter. Because I have A equals B, C equals something else, or that's not what I have written here. All right. Okay, so I'm not going to give you guys a question that's a proof like this on your quiz tomorrow, but I don't want you to forget this information about isosceles. So somewhere in some blank space on your paper, or if you want to get out an extra sheet of paper and write this information down, I just want us to make some quick notes about an isosceles triangle. Okay, so what we should take away is that triangle ABC is an isosceles triangle because it has two congruent sides. All right? And then, because of this, we knew that it had the two congruent angles, right? So because AB is congruent to BC, we can say A and C, the two angles, would be congruent. Okay, and if you you can't remember why, just maybe make a note that it's because these angles are opposite of the congruent sides. Okay. So, in a proof, you could take this information in two different ways. So, maybe in a proof, you are given that AB is congruent to BC. So that's kind of like what we just had in the proof we looked at, right? In this case, in that statement column and reason column, you could write first, you're given, right, that AB is congruent to BC because given. I then can make the conclusion that it's an isosceles triangle. Okay, by definition of an isosceles triangle. I then can draw the conclusion about the two angles being congruent. By, again, definition of isosceles. Okay, that same information could also go the other direction. Okay, so if all they told you is that you are given that angle A is congruent to angle C, you could write the same proof in the opposite order. Okay, so you could make your statement and reason columns. Okay, this time you'd have angle A congruent to angle C because given. Okay, and then you could say that you know it's an isosceles. Because definition of isosceles. And then draw the conclusion that those two sides are congruent. So AB would be congruent to BC because, again, definition of isosceles. Okay, so that information could go either direction. They could give you two congruent sides, or they could give you two congruent angles, and you're going to know that it's an isosceles triangle, and then you can draw the conclusion of the other congruent sides, right?